In the good old days, finding a parasitic drain on a car was much like finding one on a bike. Very simple process. You would simply get your multimeter, set it to amps, put the red in the amp socket, black in the COM socket, remove the negative lead, and you would then put the red multimeter wire on the negative lead, the black multimeter wire on the negative battery terminal, and you would check your current drain, and it would always be 0. I'll show you that now. So the multimeter's on the milliamp scale. It's on 20 milliamps, so it will read anything from 0 to 20 milliamps, and there's nothing, and that's because when the key is off, when the ignition's off, the key's removed, the vehicle is asleep completely. But unfortunately it's not like that on modern cars, so you have to approach it a little bit differently. Okay, well, people will say that you need to have a fully charged battery. I can't honestly say that I've noticed any difference between having a fully charged and low battery, but anyway, my battery is fully charged. There we go, 12.89 volts. It's brand new, basically, the battery. So what we need to do now is get the multimeter set up just the same as I just showed you on the motorbike, and we're going to get it connected to measure the current drain. I'm going to be using my Fluke Multimeter it just makes things a whole lot easier for me. It's auto ranging, so I don't have to mess about, so I've just got it set to DC amps, red lead in the amp socket, black in the COM. That's very, very important. Make sure your lead's in the correct socket. If you've got a manual ranging multimeter, you want one that's minimum 10 amps. I'm working with a 10 amp multimeter. Some people say 20 amps is better, and I tend to agree, really. 20 amps would be better, but there we go. And the reason 20 amps could be better is just even when you're activating the central locking, that can draw more than 10 amps for the motors in the lock, so you can run a risk of overloading your meter, so you do this at your own risk. So yeah, if you've got a manual ranger one, set it on the 10 amp setting just there, and then just move it down to the 200 milliamps, dependent on what your reading ends up being. So I'll move that out of the way to avoid confusion. So with the Fluke, what I've got the leads here. I've already got the black lead connected to the battery there. I'm using clamps. Makes life a whole lot easier if you use clamps. And there's the battery lead that I've disconnected just down there, and I'm just going to put the red lead onto it, and make sure you get a good positive connection. So there goes my alarm, which is to be expected because it thinks the car's being broken into. Okay, so that's current. So now your multimeter is in series with the battery, so that is the current current drain. Okay, so there's 4.4 amps being drained. Let's just put it in there to get rid of some shadows. Okay, so we've got 4 amps at the moment, and you can see that even just by activating the central locking, if I lock it goes on to overload there, so that's why you have to be careful. Okay, so all I'm going to do now is lock the car, and I'm just going to leave this car for 15 minutes. Some cars you have to leave for 20 or 30 minutes, and basically the car thinks everything's asleep. Now what you'll be thinking is, if the battery's in the boot, how can you leave the boot open? Well, it's very simple on this. All I did on the boot lock was push the catch in till it clicked, and so now the system thinks the car is completely closed and will go to sleep properly. if it didn't think it was closed, my indicators wouldn't flash, but as you can see, my indicators flash. So I've fooled the car into thinking that everything's closed, and all I'll do is let the alarm set, let all the systems shut down. That 4 amps will go down very, very quickly within the first 2 or 3 minutes, and then it will slowly but surely settle at the final figure. And the final figure that I'm looking for is on this particular car, the Volvo specified figure is, see how quickly it's going down now? So we're now down to 358 milliamps, 0.358 amps. It will go down further. The specified draw for this car is 37 milliamps, or less than 37 milliamps. So that would read 0.037. So anything over that is over spec. Now Volvo do specify like a 20% variance, if you like, so 20% on top of 37 is around about 45. So if I can get it to, you know, around 45 milliamps, then really that current drain is acceptable for me. So I'll leave it for 15 minutes, let the car fully go to sleep, and then we'll see where we're up to. Okay, well, let's take a sneaky peek inside the boot and let's see where we're up to. Okay, so I've left it for the full 15 minutes, and as you can see, I have an over spec parasitic drain. So we're at, see, this is the other nice thing with this multimeter, I can just set minimum and maximum. So if I run minimum and maximum just for a few seconds, we'll suss it out. Okay, so the maximum figure is, minimum figure is 79, average is 81, maximum is 90. So that's, you know, roughly twice what it should be. So what I'm going to do now to make fuse checking easier, and you really don't want to be fuse pulling on a modern car, because if you do fuse pulling to find a parasitic drain, you could be there forever, because if you pull something and then replace the fuse and it wakes that system up, your reading will suddenly fly up and you'll be all over the place, and you'll never get it. So I'll show you a method that works for me quite nicely to find what the drain is. So all I'm going to do now is get the car unlocked and get it ready to do another test. Okay, so this is where you need a bit of lateral thinking. So in my boot, I've got a fuse box just there. Okay, so I've got a load of fuses there. I've actually got 3 fuse boxes on this car. So I've also got a fuse box at the end of the driver's panel just there. Okay. And then I've got a fuse box under the bonnet. So because I've got so many fuses to check, while still making the car think it's asleep, I've basically got to do that lock trick on other parts of the car. So on my driver's door lock, make sure it's pushed in twice, and then I'll be doing the same on the bonnet catches. So I've actually got 2 to push down there as well. So there's 1 on that side and then 1 there. Okay, so even though the car boot is open and the driver's door and the bonnet, if I go to here, I can lock and unlock the car, and the car thinks everything's closed because it's setting the alarm and flashing the indicators. So what I'm actually going to be doing is leaving the car unlocked, and and I'm not going to lock it or set the alarm, because what I want to do now is make the car think it's asleep, but check the current drain without the alarm being set, and just see what the difference is between before and after. Okay, so I've left the car this time for about half an hour, because if you don't fully shut down the car by arming the alarm on this car, it takes around about half an hour for everything to shut down, rather than just 15 minutes if you're setting the alarm. So it's good for me to see that the current drain is still around about the same as when the alarm was set. If I set the minimum maximum just for a few seconds, what I can see, I think previously before the maximum was 90, wasn't it? Something like that. So now we've got a maximum of 81, minimum 73, average of 76. So if the maximum's 81, previously it was 90 with the alarm set. So the alarm is only making a 7 milliamp difference, so hardly anything at all, and that's good news for me, because I actually fixed the alarm a couple of years ago, so I'm relieved that fix is still going. So now we've got the problem of finding exactly what's causing, this particular draw here, and it can be a couple of things really that I normally find. It's either a fuse, that's the most obvious, or rather a circuit connected to a fuse, or it could even be just a dodgy earth connection, and the car's got, well, lots and lots of earth connections. So I'll show you how to check the fuses first of all. Now if you've only got one multimeter, you'll at this point you'll have to disconnect it, put the battery lead back on, and you'll have to leave the car again for half an hour, all right, before you can do this test, because you need the car to go back to sleep. I've got two multimeters, so I can leave this just running as it is whilst I conduct my tests. Okay, so I'll show you on this fuse box, just because it's the easiest one to set up the camera, but I'm going to do this for literally every fuse, so the one in the the end of the dash, the one in the boot as well. Now you notice on the fuses they've got small metal contacts, okay, and that means you can access what's happening with the fuse without actually removing the fuse. So I've got my multimeter set this time. Make sure you transfer it over from the amps into volts, and I've got it set on the lowest DC volt setting, which is 200 millivolts. And all I'm going to do is just put each of the leads, all I'm going to do is put one lead on one side of the fuse and the other lead on the other side of the fuse, and basically on a system, if the car is truly asleep, or if the system this is connected to is truly asleep, I'll get a 0 reading. I won't even get a single millivolt coming. So all I'll then do is any fuse I find where I'm getting a reading, and you'll need to be very methodical with this, and you just work your way through all of the fuses, but it's quite a quick way of checking. Every time you get a reading, just make a note of, don't remove the fuse, whatever you do, just make a note of exactly what that fuse is, the number, which location and what have you. So when you've checked every single fuse, then you can assess whether you're going to remove that fuse to see if it affects the current drain. So I'll get testing these now, and I'll show you how quick it is. Okay, so I'll just start at the top and work my way down. So nice contact. Just do a count of 3 with every fuse. So 1, 2, 3, and look for a reading. It should be 0. 1, 2, 3. 1, 2, 3. And I'm just going to do that with every single fuse. Good contact on it. Like I say, if I get any reading at all, don't remove the fuse, just make a note of which fuse it was, and I'm going to do that for every single fuse in the car, and then we'll see where the readings were. Okay, so I found, of all the fuses, I found 3 where I'm getting a reading. So I'm getting a reading of 0.3 millivolts. Okay, so it's a tiny current going through that. So that's on that fuse there. I'm getting 0.2 on that fuse there and 0.1 on that fuse there. So everything else under the bonnet, there was no reading at all. So if I go through my list, let's try and get this settled down. Okay, so it was fuse 28, which was the roof lamps, courtesy lamp, UEM. UEM on this car means upper electronic module. Now there's no courtesy lights on, nothing's on in the car at all. And that doesn't overly concern me because the alarm system is part of the UEM on this car, so 0.2 millivolts isn't really a concern. The other one was fuse 38, that's the alarm siren, the alarm system, that was 0.3, 0.4 millivolts, and then the other, which was 0.1 millivolts, was the audio. Now I think that's probably the keep alive memory, just to store all the stations and what have you on the stereo system. So there's no smoking gun that I've found there, unfortunately. So if I pull those fuses, I'll show you what happens when I pull those fuses and show you what happens to the voltage, to the current draw. Okay, so it was the alarm, and it was that one there, and it was number 20, not number 20, this 20 amp fuse. Okay, so now the current drain has now gone to an acceptable level. We're now at well, there we go, it's no more than 20 milliamps. So we've got a max of a minimum of 16, average of 18, maximum of 26. So one of those 3 fuses is causing the biggest drop, because that's dropped 50, best part of 50 millivolts. So what I'm going to do now is put those back in. Now if I get a massive jump back up here and it goes back over that 70 odd millivolts, then I'm going to have to start the whole process again. So I'm hoping that won't happen. So I'll put one back in at a time. So this is the audio one going back in. That was causing a current draw, and that's caused it to go back up over that figure. So it looks like there's something going on with the audio system, but I'll keep trying. So I'm now going to take the audio out, and I'm going to put in this UEM with the courtesy lamps and everything. It hasn't turned anything on, that's good. So let's see what difference that makes. Okay, so with the UEM upper electronic module fuse back in, very low, so I'm going to leave that in. So I took out the audio and the alarm is still out as well, so I'm going to put the alarm back in and just leave the audio out. So in goes the alarm. We'll see what that does. Now normally on a Volvo It is the alarm that's the problem, but I don't think it is in this case. Okay, so the alarm fuse is back in. So the only fuse missing now in the whole car is that audio fuse. And with the alarm fuse in, as you can see, we've got 32 up to 37. So the maximum's 38, minimum 32, average 34. So it looks like we've found the problem component, which is the audio system for some reason. So just to confirm now, that's the audio going back in. You can actually hear the CD changer just booting up, but it shouldn't turn on any other modules. And yeah, so without the audio fuse, every other system in the entire car produces 37 milliamps. If I've said millivolts at any time on current draw, I'm sorry. 37 milliamps from every other fuse, and then I put the audio one back in, and it doubles it just on its own. So I'm not too sure what's happened there. Now the only thing with my audio system, I have got a Bluetooth device wired into it that I put in maybe 2 years ago. It's called a Grom, but it's on a switched live, so that's why I'm confused, that even with the ignition off, key off and everything, and it's built into the audio switch live, so I'm not too sure what's going on there. So all I'm going to do is investigate possible earth connections or whatever, because I don't think the actual system itself is a problem. It seems to be working okay. But anyway, the main thing is how I sort that really shouldn't matter to you too much. The important thing is that by going through all those funny little procedures, and you just have to be methodical and careful and check absolutely everything, but hopefully I've shown you a way where you can find your current drain. And if, like me, you find the problem fuse but it's not obvious, you know, but the component works okay or seems to work okay, then, you know, check big obvious connections, all the earth connections, remove those, clean them up, make sure they're corrosion free, make sure it's bare metal on everything. And that's all I'm going to do. I'm going to work my way around and just make sure every single earth connection is okay, because I think the problem may well lie there. If that doesn't bear any fruit, I'll have to take off the Bluetooth device in order to get the current drain to an acceptable level. But still, on my car, if that current drain of 70 odd milliamps on a 90 amp hour battery, which is what this is, it's a 90 amp hour battery, it's not a colossal drain on it, and I use the car every day, so I'm not going to have a situation if I leave the car over a weekend that I'll have a flat battery. I could really leave the car with that drain going on for 2 or 3 weeks and still be able to start the car, but it's higher than the spec it should be for the car, so I'll need to get it sorted. But anyway, that's my method for finding a parasitic draw. And if you can't find the exact figures for your car, a rough estimate is to get 0.050 amps or 50 milliamps as your target, and ideally get it around there and under that figure. So that's that. Thanks very much for watching, and I hope you find all that useful.